Hello, we are looking at HSC 2014 Mathematics paper, question 16, part A. Use Simpsons rules with 5 function values to show that the integral from minus pi on 3 to pi on 3 of sec of x dx is equal to pi on 9 times by 3 plus 8 on root 3. Of course, the Simpsons rule is an approximate rule, and so it does not give you the exact value except in some special cases. What we are trying to do, we are trying to approximate this integral and without actually finding the integral, get some idea of how much that integral would be. Of course, we can use it only for integrals with limits. Okay, for Simpson rule, basically you got the formula that h on 3 and times by f of x0, that's the first value of the function, plus 4f of x1 plus 2 of f of x2 plus 4f of x3 and so on, and eventually you got f of xn. These are the function values. F of x0 to f of xn are the function values. H is the value of each subinterval. And as you can see, the first function value, which is f of x0, has no coefficient or just 1. And the last one also has no coefficient, which is only 1. But then alternately it becomes 4, 2, 4, 2, 4, 2, and so on, until you get to the last one. Okay, to find the subinterval, we need to see how many, to find the values, these x0 values and x1 and x2, x3 and all that, we need to find the length of subinterval. What's happening here, if I put my x values, and the first x value I have is minus pi on 3, so I write it here. That's my first x value, which is the same as x0. The last x value is again my other limit of the integral. So that is my xn, pi on 3. That is xn. But depending on the requirements of the question, you need to find the value of n. The question goes like, use Simpson's rule with 5 function values. So I have 5 of this, f of x0 to f of xn. I have 2 of them, and I need to find the rest 3. One thing also we should be noticing is how many subintervals we have. So we need to find the number of subintervals. Number of subintervals, which is the length between each subsequent x values is 1 less than the number of functions. So they say 5 function values. So we have 5 minus 1, which is 4. So we have 4 subintervals. That means that the length between the lower limit of the integration and the upper limit of integration, this length has to be divided into 4 parts. So first then I need to see how long this is. To find how long this is, I take away this from that. So pi on 3, take away minus pi on 3, which becomes pi on 3, 2 negatives makes positive. So pi on 3 plus pi on 3 is 2 pi on 3. So I've got 2 of them, 2 times pi on 3. Okay, that's my total length from here to here. Now I need to divide this by 4. 2 pi on 3 divided by 4 is 2 pi on 3 divided by 4 on 1, and I need to flip and time. So I flip the second fraction and time, so that gives me 2 pi on 12, it simplifies to pi on 6. Okay, so this is the length of each subinterval. So length of each subinterval. What I need to do is to go from one x value to the next one. I need to add that subinterval. So I'm adding pi on 6, okay, to get to this value, and keep doing that. So minus pi on 3 plus pi on 6 minus pi on 3 plus pi on 6. That will give me minus pi on 3 plus pi on 6. We can factorize for pi. So you got minus 1 on 3 plus 1 on 6. It becomes pi. That, if you work it out, becomes 1 on minus 1 on 6. So that becomes minus pi on 6. So minus pi on 6. For the next one, I'm going to add another pi on 6. Okay, minus pi on 6 plus pi on 6 is just 0. And I need to add the last one because to get this, because I've got the last value. Remember now, this is x4. Okay? This is x4 because we have 4 subintervals. Now 0 plus pi on 6 is pi on 6, and you can check out your working out by adding pi on 6 plus pi on 6. You should end up with the last value. If it doesn't, then you made some error during your calculations. Okay, now we got all the x values that we need. These are the x values, but in the formula I don't need just the x values, I need the value of the function. So I'm going to make another table and to find the values of the function for these x values. So my x values are minus pi on 3, minus pi on 6, 0, pi on 6, and pi on 3. My f of x values, remember f of x in this case is just whatever you have inside the integral, which is sec of x. So sec x. And you know that sec of x means 1 on cos x. Now f of minus pi on 3 is equal to 1 on cos of minus pi on 3. And for cos, negative or positive doesn't make any difference. So it either you have a negative angle or positive angle, the cos is the same. So I can write it as cos pi on 3. And cos pi on 3 is a special angle and it's equal to half. And 1 divided by half is 2. So that becomes 2. I sub in the rest of the x values and find the corresponding function values. Then for this one is 1 on cos of minus pi on 6, which becomes 1 on, again, a negative doesn't make a difference, negative angle. So cos pi on 6 is root 3 on 2, and 1 on root 3 on 2 means the reciprocal of that, so it becomes 2 on root 3, so 2 on root 3. For 0, 1 on cos 0 is 1, so 1 on 1 is just 1, so that becomes 1. For the rest of this, I don't even need to find them out, because minus pi on 6 and pi on 6, we said that negative angle doesn't make any difference to cos, so 1 on cos for all of them will be the same. So I've got already minus pi on 6, I can use it for pi on 6, and minus pi on 3 will have the same value as pi on 3. Now I've got my table. I'm going to use this formula to find the value of my integral, or an approximation to my integral. So that will be minus pi on 3 to pi on 3 of sec of x d of x is equal to h. We said h is the length of each subinterval. The length of each subinterval is pi on 6. So you put pi on 6 over 3. And now f of x0. F of x0 is 2 plus 4 times f of x1. F of x1 is 2 on 3 plus 2 times f of x2, that's f of x2, that is 2 times 1. So you can also, to avoid confusion, you can start with that, say f of x0, or maybe I can say this is x0, x1, x2, x3 and x4, and then these are going to be f of x0, f of x1, f of x2, f of x3 and f of x4. Okay, so 2 times 1 plus, now the next one is 4 times 2 on root 3 plus, now I'll go to the last one, which is 2, and I write just 2 because it doesn't have any coefficient, just stuff. So pi on 6 divided by 3 is pi on 18. So to divide a fraction by 3, and times the denominator by that number, by 3. Now I've got 2 plus 2 plus 2, which is 6. I've got 4 203s, another 4 203s. Altogether, 8 times 203s, which becomes 16 on root 3. Almost there. All you need to do is factorize for 2 in the brackets. You get pi on 18 times by 2. If I take out 2 here, I'm going to have 3 plus 8 on root 3. Okay, and that simplifies to pi on 9. You get pi on 9 times 3 plus 8 on root 3, which is the answer they are asked come up with. Yeah, just for this Simpsons rule, remember that this is your subinterval, the length of your subinterval, which you can find by finding the length of the length of distance from the first value of the integral to the end value of the integral, the values that are already given to you. You find that by subtracting them. And the next thing is you need to find the number of subintervals. The number of subintervals is 1 less than the value of 5 function. The value of function values. In this case, it was 5 function values. So 5 minus 1 gives me 4. Okay, so so basically that means n is equal to 4. And your x values are the first value of the integral, is always x0, and the last value is xn, which is, in this case, n is equal to 4. And as I said, n is nothing but the value of the number of function values take away 1. Thank you for watching.